In this video, what I'm going to discuss is all about acid-base balance. To start, uh, there are four major acid-base disorders. Namely, we have your metabolic acidosis, no? We have your metabolic acidosis, metabolic alkalosis, respiratory acidosis, and respiratory alkalosis. Okay? So let's define first what do we mean by metabolic and what do we mean by respiratory. So once we said metabolic, these are a group of disorders that primarily involve bicarbonate concentration. Again, these are acid-base disorders which primarily involve our bicarbonate concentration. Meaning to say, in metabolic, we have either decrease in our bicarbonate, no, or increase in our bicarbonate. Okay, again, the major problem or the primarily involved in metabolic diseases in relation to acid-base disorder is your bicarbonate. While for respiratory, again, this is a group of disorder or a disorder that primarily involves our carbon dioxide concentration. Like in metabolic, no, the total concentration of our carbon dioxide is either increase or either decrease that can lead into what we call alkalosis or acidosis. So first, let us define what is metabolic acidosis. When we said metabolic acidosis, the primary organ or the primary definition of what we call metabolic acidosis is because of the defect in our bicarbonate. Meaning to say, our bicarbonate here is decrease. Okay? Our bicarbonate here is decrease. Having said that, okay, having said that our bicarbonate is decreased, no? The problem is that our our pH is being affected because as we all know, our bicarbonate is the one, no, our bicarbonate is our buffering capacity or has the potential to, no, to buffer, okay, to neutralize our pH. In this case, no, there is a defect or deficit, no, which means decrease in our bicarbonate. Now, in metabolic acidosis, it is important that the ratio of our bicarbonate and carbon dioxide is 20 is to 1. Okay? 20 is to 1. 20 is to 1 ratio of our bicarbonate and our carbon dioxide leads into what we call decrease in pH. Having said that there is a decrease in pH, no? Having said that there is a decrease in our pH, then therefore our body will be on the state of acidosis. Remember, no? 7.35 to 7.45, an average of 7.40 is the normal pH. In this case, the pH of the blood or the pH, no, of the blood, yes, is less than 7.35, which becomes acidic. Okay? One of the most common conditions wherein a patient experience metabolic acidosis is what we call diabetic ketoacidosis. Take note, guys, that metabolic acidosis is common in patients with diabetic ketoacidosis. It is because of the formation of the acetoacetic acid and the beta hydrobutyric acid. No, the main reason why a patient with diabetic ketoacidosis, no, uh, develops metabolic acidosis is because diabetic ketoacidosis, no, is capable of producing your ketone bodies such as your acetoacetic acid and your beta hydroxybutyric acid. Both are all acidic, okay, in nature. Another condition wherein a patient can develop metabolic acidosis is that there is what we call lactic acidosis. Okay, lactic acidosis is due to the overproduction of what we call lactic acid. Okay? Poisoning such as salicylate, ethylene glycol, and methanol or methyl alcohol can lead into what we call metabolic acidosis. Okay? Reduced acid excretion due to renal failure or tubular acidosis is also a condition wherein a patient could develop metabolic acidosis. One of the condition is your renal tubular acidosis or RTA, wherein nagiging alkaline ang urine being excreted but the tubules is acidic. Okay? Loss of bicarbonate, again, is the most common reason why a patient develop metabolic acidosis. Take note, guys, that the loss of bicarbonate is due to diarrhea or excessive renal excretion of our bicarbonate. Now, what are the laboratory findings in the cases of metabolic acidosis? So there will be a decrease in carbon dioxide. There is a normal partial carbon dioxide, and decrease in the pH. Now, since that we have here a metabolic acidosis, and if we are going to recall, the ratio 20:1, 20:1 for our bicarbonate and carbon dioxide is being affected, and metabolic acidosis, the compensatory mechanism is what we call the respiratory compensatory mechanism. Okay? Mababa po ang ating carbon dioxide, normal ang ating partial carbon dioxide, then what will be the compensatory mechanism of our body? Okay? So again, we have here your respiratory compensatory mechanism, and one of the most common thing is your hyperventilation. Okay? That is the most common, what you call this? Compensatory mechanism of a patient who is experiencing respiratory acidosis. So nagha-hyperventilate siya. Bakit siya nagha-hyperventilate? Because of the decrease in pH, Decrease in pH, okay? Decrease in pH or decrease, in pH or decreased pH triggers our hyperventilation. Okay? Kapag po nagha-hyperventilate ng isang pasyente, it lowers the partial carbon dioxide, It lowers the partial carbon dioxide and increases the pH into normal 1. Okay? Increases our pH into the normal pH, which is 7.45 or 7.35 to 7.45. Okay? So again, if there is a metabolic acidosis, the problem is that there is a defect or deficit rather in our bicarbonate that leads into increase in our pH. And the compensatory mechanism of the respiratory system is to hyperventilate so that it will triggers, so that it will lowers the partial carbon dioxide and increases our blood pH into a normal range. On the other hand, we have your metabolic alkalosis. In this condition, if there is a deficit in bicarbonate in acidosis, then therefore in metabolic alkalosis, there is what we call bicarbonate excess. Okay? There is what we call bicarbonate excess. And this is primarily because ingestion of excess base. Okay? Ingestion of excess base may cause by ingestion of what you call this? Antacids. Okay? Loss of loss of hydrochloric acid after vomiting can also be the reason why the patient experience metabolic alkalosis. Okay? Loss of hydrochloric acid, HCl, the gastric acid, because of vomiting, intestinal obstruction, or gastric suction could be the reason why there is what we call alkalosis, for the loss of acidic fluids. On the other hand, there is what we call renal bicarbonate retention. Instead of nire-release siya, inabsorb ng nire-absorb, ni tubules ang ating bicarbonate na nagiging dahilan why our body becomes alkalosis. Remember guys, that our kidney is the one that is responsible for the regulation of acid-base balance. Okay? Prolonged diuretic use and loss of hydrochloric acid, like what I've said, no, loss of acidic fluids. This is in connection to each other. That's the reason why a patient could develop metabolic alkalosis. So what are the laboratory findings in compensation? So we have your total concentration of carbon dioxide is increased, partial carbon dioxide is normal, and of course our pH is increased. And therefore, again, take note that this is a metabolic alkalosis. Metabolic acidosis is hyperventilation. Now, in metabolic alkalosis, the mechanism of the body is to do hypoventilation. Okay? Take note, guys, that the pH increases, no, slows breathing. That is what we call hypoventilation. Okay? Tumataas po ang ating blood pH kung tayo po ay mabagal ang paghinga. Okay? Hypoventilation increases blood pH. Take note, the pH increases, slows breathing. That is your hypoventilation. Then therefore, it will cause increase in the amounts of our carbon dioxide. Okay? Increase in the amounts of our carbon dioxide that is being retained in our lungs. Having said that, increased carbon dioxide retention causes increase in the causes the increase of our carbonic acid. Okay? Increase in the carbonic acid, which resulted to lowering the pH. Okay? So that it will be normal. Okay? So that it will be normal. Now, what are the laboratory findings in the compensation? So we have your total calcium or total concentration of carbon dioxide increase, partial carbon dioxide increase, and the blood pH is normal. So again, in metabolic acidosis, hyperventilation. In metabolic alkalosis, we have your hypoventilation. So this time, we are going to discuss what do we mean by respiratory acidosis. When we said respiratory acidosis, that is primarily due to partial carbon dioxide increase. Okay, increase in partial carbon dioxide, and that is what we called hypercapnia. Okay, so when we said hypercapnia, it is increase in the carbon dioxide in the bloodstream. Okay, a patient with respiratory acidosis will develop hypoventilation. Inability of the person to exhale carbon dioxide through the lungs causes increase in our partial carbon dioxide. Again, those patients experiencing respiratory acidosis can develop hypoventilation. Again, can develop hypoventilation. Bakit po nagkakameron tayo ng hypoventilation? Or bakit po nagkakameron tayo ng respiratory acidosis? Okay? Hypoventilation causes increase in our partial carbon dioxide. And that is the main reason why the patient has respiratory acidosis. Take note that the increase in partial carbon dioxide causes increase in the concentration of the dissolved carbon dioxide, which forms carbonic acid in the blood. Therefore, this decreases the 20:1 ratio between your carbonic acid and your dissolved carbon dioxide, which resulted to decrease in the blood pH. Okay? So conditions that develop or patients with chronic bronchitis and emphysema, ingestion of narcotics and barbiturates, and even meningitis will develop respiratory acidosis. So these are the laboratory findings in respiratory acidosis. So we have your total concentration of carbon dioxide is normal. Partial carbon dioxide is increased because of hypercapnia due to hypoventilation and decrease in the blood pH. No? Therefore, the mechanism of the body is through the actions of the kidney. Okay? So through the actions of the kidney, there will be what we call sodium-hydrogen exchange. The sodium-hydrogen exchange increased by carbonate concentration that aids the return of what we call 20:1 ratio, which rises the blood pH. Okay? There will also be a formation of ammonia and retention of bicarbonate for homeostasis. Thus, therefore, we will expect that the patient will develop increase in total concentration of carbon dioxide, increase in partial concentration of carbon dioxide, and normal pH. Last but not the least is we have our respiratory alkalosis. This time, there is a decrease in partial carbon dioxide, and that is what we called hypocapnia. Okay. Take note, guys, that the decrease in partial carbon dioxide results from an accelerated rate of or depth of respiration. Okay, malalim na paghinga or a combination of both. Okay? Hyperventilation is being experienced by patient with respiratory alkalosis. Remember that excessive exhalation or of carbon dioxide, no, this should be off. Okay? Excessive exhalation of carbon dioxide reduces partial carbon dioxide, causing decrease in the concentration of the dissolved carbon dioxide, which forms less carbonic acid in the blood. For example, there will be a less hydrogen ions that lead into increase in our pH. Now, this increases the 20:1 ratio between your carbonic acid and your dissolved carbon dioxide, which resulted to increase in the blood pH. Hypoxia, anxiety, nervousness, excessive crying, pulmonary embolism, pneumonia, and congestive heart failure are the conditions wherein a patient could develop respiratory alkalosis. So what are the laboratory findings in respiratory alkalosis? Increase in pH, total concentration of carbon dioxide is normal, and partial carbon dioxide is decreased. Now, our renal compensatory mechanism is through the excretion of bicarbonate. Now that we excrete bicarbonate, so hindi na nare-retain, no? Nare-retain kasi, di ba? Doon sa respiratory alkalosis, no? Kailangan mag-hyperventilate ng pasyente natin. Bakit? Para po tumaas ang ating pH. Para mag-normal ang ating pH. Kasi di ba, kay metabolic acidosis, nung nag-hyperventilate, bumaba yung at nagkameron tayo ng problem sa ating bicarbonate deficit. Ngayon, kay respiratory alkalosis, excess naman tayo ng bicarbonate. So, the mechanism of our kidney is to excrete the bicarbonate so that there will be a normal in pH. Then therefore, we are expecting that the patient will develop decrease in the total concentration of carbon dioxide, decrease in the partial carbon dioxide, and normal pH. Okay, so there is a recall in the board exam and the question goes like this. For every increase in 37 degrees Celsius, ano daw po yung may experience ni pasyente? Ano daw po yung may experience ni pasyente? Okay. Para masagot po natin tong tanong na ito po yung palatandaan ko po sa inyo. Nung pong ikaw ay college, kapag tres, pass. No? Nung ikaw ay elementary, kapag 70% ang score mo, bababa. Okay? So, for every increase in 37 degrees Celsius, what will be the consequence? Okay? Tandaan, nung college ka, kapag 3, pasado na, mataas. Kapag nung elementary ka, kapag 70, mababa. Okay? Pag line of 7 ang grade mo, mababa ka. Therefore, decrease in 7% in your partial oxygen and no, not this one, this one. Decrease of 7% in your partial oxygen and increase in 3% in your partial carbon dioxide. So again, take note, for every increase in 37 degrees Celsius in the temperature, a patient will develop decrease of 7% in partial oxygen content and increase of 3% in the partial carbon dioxide. Okay? So to synthesize, okay, kapag po tayo ay mayroong metabolic acidosis, bicarbonate deficit, ang compensatory organ natin lungs, at ang gagawin ni lungs magha-hyperventilate. Kapag po tayo ay mayroong metabolic alkalosis, may excess po tayo ng ating bicarbonate. Ang compensatory organ natin, lungs, ano po ang gagawin? Mag-hypoventilate. Take note guys that hyperventilation lowers partial carbon dioxide and increases pH, while your hypoventilation increases carbon dioxide and retained by the lungs. Kapag po tayo ay mayroong respiratory acidosis, ang atin pong compensatory organ is the kidney, and our compensatory mechanism is magkakameron po tayo ng sodium-hydrogen exchange, formation of your ammonia, and retention of your bicarbonate. Kapag po tayo ay may respiratory alkalosis, again, the compensatory mechanism is the renal or the kidney, and the mechanism is to excrete excessive bicarbonate. Okay? So that there will be a normal pH of the blood. And that concludes our discussion about acid and bases. So thank you very much, and I hope you learned.